Dzień dobry. I will be talking about ROS. So, guys, I need to first know how many of you heard of ROS, and hands up. That's great. That is great. Okay. So the original name of the original title was Ecosystem for Things, but I actually renamed it to Middleware for Things because this is what BMW company calls ROS. Okay, so small game. Which one is fake? A doorbell that reveals your home Wi-Fi with a use of a screwdriver, sewage pipe that analyzes home sewage, basically shit, to inform you about your possibility of, I don't know, a disease or something. Unsecured Niagra, the name is actually very relevant here. HTTP server exposing VNC interface for management of the toilet, probably industrial toilets. Chat with your dog over internet, a two-way video chat with your animal. Smart TV that self-bricks itself. You can tell that it's true. Yeah. Who casts viruses out of your computer with magic. An iKettle, you probably heard about iKettle. A kettle that lets you boil water anywhere in your home and welcomes you by asking if you'd like to pop the kettle on. I don't know, pour the water. It chimes. Like when you come home, it says like, "Give me some water" or something. Clear channel outdoor ad with blue screen of death. Bulb that you can control with your smartphone. Yoga pants that give you vibrations, haptic feedback when your upward dog is wrong or just incorrect. Okay, so which one was fake? Screwdriver? No. None. When I was writing this presentation, this was not true. But I found out over the internet that they are working on this. So none are like fake. So this is how ancient people imagined Internet of Things now, which is 2016, in 2012. Connected wearables, cars, security, like intelligent mesh of devices that help you have a better life. But instead we have something like this, or this is one of the examples. This comes from great Twitter account, Internet of Shit. You should look it up. This was posted on Internet of Shit today. This is kind of like what we have, what we get when, like, those are probably the worst cases here, but this is what Internet of Things is right now. The abbreviation or the longer form for Internet of Things is also the Internet of Things you don't need. So let's go back to the Niagra server. That is true, like Niagra server that I presented you actually exists. This screen comes from Shodan.io. So how many of you know what Shodan.io is? 1, 2, 3, 4, 5, 6, 7. Everyone, please open Shodan.io once I'm finished, or you can do it now. Shodan.io is a service that scans through the whole internet, discovers Internet of Things or devices that are connected that are not web servers like Apache, Nginx, etc., and takes a screenshot, just gets headers, and it comes out that in headers you often get information about the default password to your camera or default password to this thing, which is a toilet. And you can probably flush the toilet remotely via VNC. I don't even know. Like I haven't tried it. So the statistics for this particular thing, this toilet will serve as an example to show like what are the current pitfalls, what are the problems with internet, and how can we address them later. Okay, so you see that there are like 2,500, almost 2,500 Niagara servers in the United States that are absolutely non-secure, open. You can probably, as I said, I haven't tried it, but you can probably go there and flush the toilet like you are crazy, like there was no tomorrow. Top versions of HTTP server. This is another great graph. It shows how diverse the versions are, which means how not updated, how non-maintainable Niagara server is, and how producers or manufacturers of this Internet of Things device haven't thought about, hey guys, what happens if we, for example, forgot to, I don't know, remove some crucial data, or if there is a security problem with our server, how do you update it remotely? Like, what do we do? note, you probably won't be able, that the first version on the list is 1.1, and the next version, all the next versions are 3 point something, which is kind of weird because you can tell, okay, 1.1, it's probably just the super legacy MVP first release that they released automatically on the production, which is just not updatable. You need to send the device back to the manufacturer, I guess. So let's talk about pitfalls of Internet of Things. Obviously, there's no known set of standards. This is the most famous XKCD that I know about standards. Let's just create another standard. So this is what this is like, you know what's NIH, not invented here syndrome. This is what Internet of Things is all about right now. Like, we need to program something new. We'll probably use Arduino to prototype it or something very common, but once it's done, we'll just come up with our own protocol, our own framework, our own language, our own, I don't know, whatever, and won't share it with anyone because it's so super edgy, non-stable, and everyone will know that we are shit, basically, after we reveal it. So there are no standards. Maintainability problems. So first, if there are no standards, how do we deal with maintainability? You probably know that Capistrano. How many of you use Capistrano? Everyone. Okay. So almost everyone. So you know how cool Capistrano is? And believe me, Capistrano is probably the best thing that comes with Ruby for the deployment. There's nothing like that. There's not even a concept for that in Internet of Things. So there are worse problems than maintainability and deployments. Like, the good thing with your website is that you don't physically ship it to your customers. Your customers cannot open your website and see what's on the server. This is what you care about. This is called security. What happens if you ship something to your customer? He can open it. He can get the source code. He can get compiled version of it. Like, what do you do? How do you address this problem? How do you ship the software? Like, once the software hits the device, like, how do you upgrade it? Have you tried to upgrade ROM remotely? You know what happens? Like, this is just too hard to be addressed, like, with frameworks that we have right now. So do you do online updates? Do you need to first stop the device or something? The security update for the lock that you could get that could expose Wi-Fi password with a use of a screwdriver. Do you know how they released a security update there? They released a security update in the following way. It was actually doable. They upgraded ROM. They forced push like the upgrade, which actually forced everyone that day when they forced it to wait like 30 seconds, and they couldn't just open their doors to their houses because it was updating. So because it's event-driven device, it just sleeps all the time. It just wakes up only if you open it. So it can execute an action only in the on a single event, which is open or close. There's no other way. So they decided that, okay, let's upgrade, let's release new software exactly in the time that people will be trying to get to their houses. So how do you do deployment even if you don't have ROM? Like, if you have just set a bunch of applications, do you do apt-get update? You all know that apt-get breaks after some time. Like, it's just too hardcore for people. So when you want to make a remote ROM update, it looks like that. Like, you just don't do it. It's looped. Okay, security. What are the problems with security? So you use your own bespoke, not invented here syndrome framework that you came up with. It's typically hard to update your framework, and like, because it's bespoke, because it's custom, because you created it, it won't receive security updates. That's a common thing. So because attacker has often physical access to your device, this is another problem. I already mentioned that if it's not compiled, if someone can get the source from it, there will be there's an immediate problem with security. You need to use something common that is hard to break and it's like hardcorely tested. Frameworks that exist are kind of immature because the community is not too big. Because in order to do something from the field of Internet of Things, you need to that like computer science degree is not enough. You need to be an electrical engineer. You just have to have some basics electrical engineering skills. I'm going to mention also hardware security limits like Wi-Fi. Wi-Fi, probably most of you know that Wi-Fi is just Bluetooth plus like this small layer of security, which on the beginning was WEP, which was just like, I don't know, you could basically compare it with level of encryption of, I don't know, like shifting letters from the alphabet or something like that to hide the information, crucial information from the attacker. So Bluetooth lower energy has like, if there was no Bluetooth lower energy yet, we wouldn't even be able to have like beacons in our shops or I don't know, like 300 meters range of your, I don't know, smartwatch. How long does one smartwatch last on a battery? What's the longest time? Does anyone know? 5 days? Yeah, 5 days. Of course, in the instructional, in the description. So it's Bluetooth low energy. Before Bluetooth low energy, it was like probably 30 minutes or something. So those hardware limitations are being like removed all the time, but it's just super slow and it's super hard to do it. About the security, Adam Clapper, the US Director of National Intelligence, said that they will use Internet of Things, lack of security, to spy on US citizens, and probably not only US citizens. So they openly admitted that. Please check up Shodan.io. Look how, like, it looks like internet in '96 or something. You can see password in the headers, default password in the headers. Like, this is where Internet of Things is right now. And the first mentions of Internet of Things, the first mention LG made was in 2000 when they said, okay, we are going to create internet-connected refrigerator. 15 years later, there are no good products in this niche. Samsung created a refrigerator that lets you order things from their interface. Everyone that has kids knows that this is just a bad idea. So hardware, what's the battery life? Battery life is very often a problem. So you all know that if you are able to reboot, if you're an attacker and if you are able to reboot a remote box, remote machine, it's typically exposed for at least few seconds to your attacks. Battery life is a big problem. If you need to if you reboot your device, if you reboot it frequently, you're exposing it. Always there's like a lot of entropy, and you're exposing your device to attackers. System resources, Wi-Fi, which is, as I said, just I don't think there are any devices, like small devices, embedded devices that are using Wi-Fi. They're typically using protocols like ZigBee or small Z-Wave or just small, super small serial communications. So ZigBee implementation, ZigBee stack is like from 4 to 32 kilobytes, and Wi-Fi is 1 megabyte. So there are those like hardware limitations that industry is removing one by one. Transmission range, of course, network size. For example, because ZigBee is like so small and very easy to embed. It also has some limitations, like it can create mesh networks, but the number of nodes can be like, I know there's like limit of 64 to 56, like power of 2. I don't even remember. So a lot of stuff is just not embeddable. For example, I don't know, you want to run your software written in Ruby. How do you deploy it on a watch? There's just, you don't do it. But it was entirely true 2 years ago, but it's not entirely true right now. And this is why ROS may like come start playing more major role in the Internet of Things. And it may be probably a rescue, but I will be talking about it in a second. So other problems, dealing with complexity. So if you have a fridge, it typically is just sensors plus Samsung tablets, and you just tap it, you buy stuff. Sensors are connected to it. It's kind of simple. What if your fridge talks to your trousers? I don't know. Sorry, boots. What if it like there's like a mesh of devices that you want them to be talking to each other. How do you like maintain coherent network there? Performance is often a key, often the key. So imagine you have internet connected, I don't know, an arm that's that's deployed in an industrial like place, like in a factory or something, and it needs to perform certain actions. So when the arm moves, you need to update on the position of the arm once, like let's say 100 times per second, because you need it because it's super precise. Every time you think about performance, it means more CPU cycles. More CPU cycles means more battery drain. Volatility, maintenance, deployment, etc. I already mentioned that volatility is a very big problem in Internet of Things. Like with this Niagra server, that's basically this 1.1 version is stuck there forever. It won't be upgraded because probably there's no upgrade mechanism. So how ROS and Ubuntu Snappy, which I'll be talking about, addresses these problems. This is kind of like, yeah, GIF. So yeah. Another funny thing, reset plug. So if you have an Internet of Things device in your house and it doesn't work, you buy a reset plug and you reset it. Every time it, like, for example, I know if your Wi-Fi or modem or whatever loses energy, so all other Internet of Things devices work. There is, if you look it up on the internet, this Internet of Shit account on Twitter, they posted today a microwave oven that won't work without Wi-Fi. It will finish your meal, but it won't start another meal. No internet, no meal. So how ROS does deal with complexity? This is mainly taken from a paper written by BMW company. So a few words about not complexity, but why BMW started with ROS. So European Union, as I said, free market, free invisible hand of a market, didn't provide us with common frameworks, common standards. So if there are no common standards, there must be a regulation. So EU, European Union Commission said, okay, guys, it's super shit. We need to work faster. We need a common standard. Here it is. It's ROS. This was particularly laid out on these autonomous driving systems, which is basically self-driving cars. So European Union said to like the Association of Car Manufacturers in Europe, guys, you just use ROS. It's super stable. It comes from Stanford. It was for past 8 years on the production. Just start using it. BMW produced many papers on that, and they were quite happy with ROS, and they are starting using. They already have cars, self-driving cars that are using ROS. Moreover, you all know that probably those people that know mechatronics of cars know that car has a bus inside, and there are many protocols that are used to communicate actors or small nodes inside a car. They replaced it with ROS. ROS is what they use for communication. So high-level programming languages, like, as I said, upgrading ROM written in CPU-specific assembler language on your smartwatch is just not doable, sorry, throw it away. A rich interface definition, language to specify application software component interfaces ambiguously. So, as I said, how do you instrumentate your ROM deployment? How do you deal with your code? How do you define what your code should be doing? How do you go on this meta level when you think about your product in terms of volatility and maintainability? And also, ROS is kind of mainstream in industrial. The only, I would say, most popular framework in industrial field. ROS and high performance. ROS is focused on non-blocking pattern. So everything that's written here is basically can be defined in one sentence. ROS is like a Node.js for things, basically, but it runs in a backend. It's super non-blocking thing, but it's no hippie, it's not edgy, it's stable. So how do you work with engineers that are not computer science engineers, how do you force them to use Agile? It's hard. It's super hard. Like those old languages, those old low-level languages, they're just hard to, and especially working with language that has to be run and tested on a hardware. It's hard to deal with this in an Agile way. So, as you all know, Agile is cool and it's like makes your software better. Again, I'm talking about remote update of application all the time. Software components, if they are not modular, as I said, if you produce a monolith, it's super hard for you to do any kind of management, to go beyond the logic of your code. You all know that what makes a great product is not like the quality of code. You all know that. It's a value for developers, but it's just probably buying time from the future and accumulating technical debt if you don't write good code, but it's not the good code that makes a good product. It's the maintainability and, I don't know, like going a few steps further. Oops. Yeah, Gartner's hype cycle. So Gartner's hype cycle defines typical curve of what happens with every hyping technology. For example, you all know that biotechnology, bioinformatics hyped a lot, but we are now with this particular thing. We are now here. With Internet of Things, I think we are somewhere here. Like this is slope of enlightenment. We are after disillusionment. Maybe we are just exiting the disillusionment. Phase. So, a few things about Ubuntu Snappy Core. So, Ubuntu Snappy Core and ROS, they play well together, as I mentioned. What Ubuntu Snappy is all about? It's basically a Nix OS. Yeah, hello, Sander. I know where you are. Yeah, it's basically an Nixos. If you are not into operating systems, this is basically modular Ubuntu based on snaps. Everything is a snap. Even your kernel, even like the core of your system is a snap. If you want to install another application or add something to your system, you download it from the internet and transactionally snap it to other snaps. What it means? It means that your snap needs to be statically compiled. It needs to be absolutely self-contained. And the way you install the software is absolutely transactional. You can roll it back, and it uses this super cool technique of relinking, as in NixOS. In NixOS, I think the hash there is the hash of the link is created on the basis of like input data, like software versions and stuff like that. But on Ubuntu Snappy Core, it's just a revision, like version of the software, which can be taken from Git tag if you are using Git tags to deploy your stuff. Building snaps. Snapcraft is a tool for building snaps. You have one file that defines how stuff should be built and what are the dependencies. I think that's all. You then build your stuff. You can make it public. You can create your own repo for snaps. You can upload it to a Snappy store, and then you can deploy it on. There's a drone here. You can deploy it on a mobile device onto a cloud. And it's worth mentioning that Snappy came from exactly this industry. It's very similar to how Android works in some way. Android has like those additional layers of Java stack that's used to manage the system and to like that you program behavior in. But Snappy doesn't have it. Snappy is a very bare operating system. But Snappy is all about like total isolation of applications. There's no interconnection between them. So you need to write it. And ROS is perfect connection between those systems. I will show you how they are connecting. So this is about dependencies. There's like it's something like being cat or dog human. Like some people like cats, some people like dogs, and there's like this dispute about whether, for example, whether we should be using declarative or imperative systems for deploying stuff, or whether stuff should be shared, compiled using shared libs or statically compiled. Like It's always, there are many pros and cons of every approach. So managing dependencies is in Snappy. Managing dependencies is just, there's no managing of dependencies. You just pull everything to your snap. So hands-on demo of Ubuntu core. You can check it up on my GitHub page. ROS demo. So let's go. It's a Vagrant box. You should have Vagrant in order to start using it. So SRC ROS demo, Snappy Ubuntu core demo, Vagrant up. I will just show you very basic. Oh, it's running. Very basic commands in Snappy. Oops, it's Docker command. So first, let's install something. Vim no X. Oh, there's no apt-get. There's only Snappy. Let's see how Snappy works. So Snappy help. Of course. Is it better now? Cool. So Snappy search, for example, gives you a list, I don't know, of, like from the Snappy store, you can install stuff. Let's search for web server. I don't remember whether the web server, maybe it's already, yeah, it's already installed. xkcd web server and system status Victor. So system status Victor is something that listens on 100, I think, or was it like, I don't even remember. There's probably a port. Welcome to NGNX. Maybe this one. I don't know. This is like a package that automatically we can check it. Nothing here. Maybe it's just not running. And as I said, everything comes with a configuration. So Snappy config Ubuntu core. Ubuntu core is also built with Snapcraft. So you get the information about like what's the running configuration right now. What should be running, what's like, there's a watchdog configured, information about interfaces. Everything is in one YAML file. It reminds me like a total anti-pattern of what Windows registry was back in the days, and it kind of reminds me like how dot files are working in Linux system. But every dot file is, there's only one single instance of every dot file or every YAML file here for every snap, which makes it kind of like granular and easier to maintain. So there's no apt-get. Everything is a snap and it's transactional. Updates are being delta updates, so that you don't download everything all the time. You can, like, it's super low bandwidth friendly. You don't have to pull everything all the time. Every time you want to do an update. So what is ROS? The abbreviation is Robot Operating System. It's certainly not an operating system. I have no idea why the name is using Robot Operating System. Why there's operating system in this? It certainly comes with a lot of tools and the whole environment for deployment, management, and dealing and instrumentation, orchestration, like everything that you do around your code. So first of all, I need to mention that most supported languages, I would say fully supported languages in ROS are C++ and Python. Those are the most fancy languages. They are absolutely 100% supported, but there are many implementations. And to do your own implementation, your own language, it's super simple because ROS is very bare, very minimalistic approach. So we have 4 classes here. They do stuff. They have like every class has like public method, handle something, provide something. So imagine you want to write abstract code about your fridge, your watch, your e-cigarette that chimes when there's no tobacco in it, stuff like that. You are not thinking in terms of hardware. You are not thinking in terms of where I'm running at, like what I'm doing. You are only implement your logic, because everything else is done for you. Because ROS is a pub-sub network, publisher-subscriber network, it needs to connect the nodes together somehow. So those points where nodes talk to each other, those small logical entities, they need to be talking to each other. They talk to each other via topics. They publish topics and they subscribe topics. And as I said, ROS is non-blocking. It very cares a lot about non-blockingness. And as you know, hardware has nothing to do with being non-blocking. Hardware is super blocking. Like if you want to access something in your file system that doesn't exist, or for example, NFS that points to an offline server, you all were there. Like you go to a directory, you just do ls and you wait forever, and you cannot kill this ls. So ROS assumes that you don't have to deal with hardware. And this is where hardware is going right now. Lots of hardware, small parts, small devices, they come up with ROS drivers or ROS software attached to it already. So there are topics, your class, from the point of your class, you don't know anything about ROS, anything about classes, anything about topics, anything about, like, you just have one public method, like in every class, that basically means do your stuff, like do your logic, handle the stuff, do it. You just have this public class, and later you attach it to ROS environment, telling that, okay, this class here handles, I don't know, touches on the screen. This class here handles what happens when the value of water in the tank is too low. But you still don't know anything about hardware. You don't have to refer to any like addresses in the memory. So from your classes, there are following concepts in ROS. ROS node, which is an instance of your piece of logic. ROS master, which is a communication bus, but nothing communicates through ROS master. ROS master is like a registration. All nodes register to ROS master. They say, okay, I provide this topic, I publish this topic, I would like to subscribe to this topic, I provide this service. And as you know, PubSub is an event-driven pattern, but it also provides services because eventually you will need a state and you will need to asynchronously get the state. It's always like that. Like even in functional languages, there's this, you know, everyone that uses Clojure or Scala knows that there's always like one super special, obsessively tested variable that's mutable. And it's like that here. You shouldn't be programming with state, but state is there. Because typically the state comes from the device. The device has the state. ROS doesn't have to have it. So there's ROS ecosystem. As I said, we have those classes. They publish stuff on their topics. Here you can have Python code running on a server, C++ code running on a watch, Firefox, and Chrome running JavaScript. There's also good communication stack for JavaScript. I don't know, Clojure running on a device. It's kind of a good pattern to be running Clojure stuff on Android devices, for example, because they are super Java-ish, as you know, or Ruby on another server. They can be talking to an API. There are no limitations. You know, you just write pure code in your favorite language, and you do your stuff. Just that. So here's a ROS node. Look, this is a ROS node. That much code is needed. This is what you need to add to your code that you've written in your favorite language, your class that you've written in your favorite language. And here the class is my custom logic. It comes from a module named stuff. So you do your stuff in my custom logic. And all the code that you need to add to this is exactly hidden here. Bam, here. This is what you need to do. You just publish stuff and tell that publisher will publish using message type A, and the subscriber, every time something comes on this topic, subscriber needs to execute this do your logic method. This is just, it's not hard-coded, like you can use whatever stuff you want here. So this is a more pleasant example probably for you. This is Ruby. Look how minimalistic it is. This is everything. You just run Ruby with this. You first need to like build it with ROS tools, but eventually it all becomes like from like you don't care about how is it compiled, how is it built, because this is what you care about. Like this is what you need to add to like your custom logic is here. Yeah. And I'm not Rubyist. This is probably not parsing even. Like I don't know. I don't know too much about Ruby. This is Clojure example. Look, all those examples are pretty similar. This is how much code you need in Clojure to do it. And Clojure, yeah, I know. Too many closures here. Too many parentheses. Okay, so simple ROS demo for DOM synchronization between two browsers. There's a Docker instance also on my Git repo. Yep, ROS demo Snappy Ubuntu core. No, ROS demo Docker. So OSX run, I guess, if I remember correctly. It didn't work for some reason. Does anyone know Docker? How to remove it? Let me see. Docker images. Something went totally wrong. What if I shut it down manually? What? Probably an error. Docker on OS X is funky. Okay, maybe just close, power off. Yes, power off, I don't care. Maybe it will work now. Yeah, I guess it couldn't find the instance for whatever reason, and it's now starting up. Is it? Yes, it is. Cool. Good guy OS X. It's doing its stuff. It takes some time. Nope. So probably no demo. Let me do another thing. Why don't we just remove it? Power off the machine. Power off. Remove. Remove only. ROS demo. Maybe it's somehow overlapping with this machine. Who knows? Better be safe. Better safe than sorry. Okay. So I think it was carrying its own stuff somewhere outside of this thing that we can observe here. Okay, so let's wait for a second until it converges. So a few more words about ROS. As I said, it's event-driven PubSub network, so it's very much focused on being like it's copying patterns from it tries to be functional as much as it can. So there are many implementations in languages like I know Haskell implementation, Clojure implementation. There's even R implementation, but I think it must be like I don't know if it's like super beta or someone was just making jokes or something, because it's super weird for me to like use R for something like that. I don't even if it even can play with ROS at all. So since it's PubSub network, and I think it's not going to work. Since it's a PubSub network and it's focused on non-blocking, how this non-blockingness is implemented. So every time publisher publishes a message, let's say you have a snap on your system, a ROS node is deployed on this snap. This snap is responsible for it's ready. This snap is responsible for I don't know, measuring and reporting level of a water in a tank. So every time it publishes the level of the water in a tank on a topic, it just doesn't care. It just doesn't care about whether someone is listening or not. So you can, so for the listener part, oh, it's actually working. So the listener that subscribed to this topic, it is actually the listener that cares for processing of the message. So let's say you measure the water in a tank, and there is like a valve that should open itself when there's no water in the tank. It's not blocking because one producer, the one that produces the messages, doesn't know anything about the listener, who is listening for those messages. So it won't like block on anything. It won't block on trying to add the water because it knows that because we deployed a piece of logic that subscribes to this message about water level and just does some logic on the basis of the water that's there. So also there are, as I said, instead of using topics with publisher subscriber, you can also use service pattern, which is basically about asynchronously polling your ROS node about stuff. So imagine you are a browser, and the event for water level in a tank is produced only if there's not enough if there's not enough water in the tank. You are a browser, you want to open a web page and you want to see what's the level of the water. You cannot make the event be produced, there's no way, because it's event driven. It produces event only if there is like a special interrupt, for example, for hardware, or if there is a condition that's satisfied for this to be produced. So you are this browser, you want to get the state. So this is where services come in ROS. To rescue, they come to rescue. They basically let you poll the state or expose the state of a variable from your class. There's also one smaller pattern which is called actions. So action in ROS is actually more complex or blocking operation. We can call it a blocking operation. Every time you want a blocking operation, like for example, physically move an arm of a robot, it's a blocking operation because the actuator, the one that moves the arm, needs to wait for the servo drive, like to move the arm. So every time you want to do this, you perform an action. An action is actually something that operator or actuator does and returns the state every 100 milliseconds, 1 second, half a second, you name it. It returns the state to the node that has asked for the action to be performed. And that's it. Like ROS does this only thing for you. So let's go further. I think it will converge in the background. So the demo will probably postpone a bit. As I said, there are other implementations. ROS CPP and ROS-Fi are the most native implementations. There's Go, Haskell, Java, Lua, R. You probably feel that they are trying to. It plays well with functional languages because there's also closure implementation. What else do you get from ROS? You get ROS topic, ROS graph, ROS node, ROS param, ROS WTF, ROS launch, ROS run. All those commands that let you interact with a running mesh of nodes within a PubSub network. You can, from your bash console, you can interact with it, you can debug it, you can publish messages. ROS is very strongly typed. It's obsessively strongly typed because if you deploy something, it needs to run. Like compiler, it's like Haskell each compiler, which will just whine about everything. But once it starts, it works, even if you plug the cable off. This is like the aim of the stability is the aim here. So there's a very, very rich environment and ecosystem of really easy to use applications for packaging, building, updating, uploading, and everything is stateless. Like, sorry, not stateless, but super self-contained. Every time you build a package, it's self-contained, so it plays well with this snappy idea of snapping your pieces of logic. And as I said, if everything on your system level is absolutely self-contained and non-overlapping with it, and the only layer of communication is ROS, you can be sure that you can actually make an online update. Robot is running, you just did an update. It won't fail on the floor. It's open source. It's fully open source. There is a Jenkins platform that will let you build dev packages and automatically publish it on their apt-get repositories. So you can publish a Debian package in ROS world in I don't know, in hours probably, because there's a long way of a long queue of building. Okay, so this is something that we do in my company. Endpoint is the company I work at. This is something that we develop on behalf of Google. This is basically hardware version of Google Earth with some enhancements. You can run many applications, but on behalf of Google, the stuff that we develop for them is mainly Google Earth. So we instrumentate, keep the state, manage the state, load assets, load content, show the content using ROS. Everything you see there is ROS. What? Yeah. So JavaScript touchscreen, and this is what the what the application is all about. And everything is written in ROS and other languages. It's a JavaScript touchscreen running in a browser as a service. So Chrome has this debugging socket, so that you probably know. You can do whatever you want with Chrome. You can send a comment to it, get the state, debug, change DOM, load the URL, change the URL, reload it, whatever. So we have a touchscreen that's running in a browser as a service, instrumented by ROS on an Ubuntu box that listens and publishes on ROS topics via WebSockets. There's a ROS bridge because WebSockets are kind of similar pattern to ROS. They are also event-driven. Everything in WebSockets is event-driven. Other ROS nodes on physically separate servers that provide those screens, for example, listen to these topics and manage applications that show the content on the screens, mostly browser as a service again. So we run those browsers and we instrumentate them and we manage their state. Everything deployed on a stack consisting of 1 to 7 boxes and managed by Chef on a hardware that we assemble and ship to customers. So we do everything from top to bottom in this product. How do you test that? Believe me, we weren't able to test that before we started using ROS, because in ROS, you can stop thinking about hardware. There's 99% of the entropy is in your logic. Your hardware actually is typically something that you can perfectly emulate, because you are talking to, in worst case scenario, you are talking to a serial device using a serial library in the background. So, of course, unit tests. You can test even like your assembler code and your C++ monolith with unit tests, that's obvious. But how do you do integration tests? It's simple. We use physical boxes, or we use Vagrant or Docker. We spawn them somewhere, it may be cloud, locally, on a physical box, wherever. We run, even on a development system, we run Selenium actions, click, touch events, or browser X. So there's this browser on the touch screen. We run Selenium stuff there. So tests are launched from one server. The browser is on another server. We use remote Selenium driver for that. Then we do something in this browser. It sends stuff via WebSocket, which is translated to ROS. It publishes messages to ROS domain. Those are published on a topic. There are many subscribers running in different browsers. Let's name them browsers Y and Z. We run Selenium asserts on browsers Y and Z. So we basically have remote browsers that we talk to. We run asserts on ROS, like we run asserts in between them, and we run asserts on them. It's absolutely doable. Okay, it should be questions now, but let's quickly see. Yes, it's working. So a quick demo of, oops. Cool, basic A. So this is just a super simple example. I need to do something like that. Of synchronization, of DOM synchronization of two browsers using DOM, using ROS in between. So, mysterious button, bam. Those are two physical browsers. There's no connection between them. The state is, it's not Chromebus that's doing this, it's ROS. So stuff is happening. How does it look like in the backend? So as I said, it's not, there's like, this isn't magic. This isn't a monolith that you need to debug by, I don't know, checkpoints or something. You list topics, ROS demo basic color. Let's go there. ROS topic, pub, sorry, echo, this. Let's click the button. Blue, red, green, event driven. Wow. So maybe we can even change it. Let's see. Maybe we can publish the message ourselves. ROS topic pub on this. And as I said, this is super strongly typed, so you need to do standard messages string. I don't think, okay, cool. I think it worked. So let's try blue. Oh, it worked. Green again. Yeah, it works perfectly. You can get the demo from my side. It should be, since it's Docker, it should be working just out of the box, as you saw. So questions?
You said about the snapping. How do you, for example, you've got this robot that's running, right? And you need to update its function responsible for the running, for the servos, for the running. How do you do that? You cannot just snap something new because it's already a part of what's there.
You can, actually. Here's how, and this is an excellent question. This is what Snappy is all about. Like, you deploy your stuff, you build it, converge, validate it. It's not yet functioning. The old version is functioning. It's online. The old version is online. New version is there. It's just waiting. You shut down old version, ROS. There's nothing blocking there. You just shut it down. 10 microseconds or something like that. Let's assume 10 milliseconds. If you can fit it in 10 milliseconds, it's always like your decision, your engineering decision. How long should it be? If it takes too much time, you just divide your snaps to smaller snaps. You just solve the problem of, like, shutting down your snap. You shut down your snap, you relink it, and you start the other snap. There's one more thing you can do. You can start your new snap. It will start performing your actions, and you can just shut down the other snap after starting the newer version. So it can work because it's a PubSub network. The only thing will happen, the new snap won't get access to the device. It will attempt to, like, be online and do its stuff. It will be listening to messages because everything is on this virtual PubSub network level. All the communication is there, but it won't be led to do it because it will access it will be able to access the resources that are blocked by the previous version as soon as the previous version is shut down. It's all about this kind of online updates, and it's working. It's working. If you go to Erle robot, it's ERLE robot. It's a robot that's like a Raspberry Pi robot that runs ROS. It's a quadcopter that can receive updates being in the air. It just works.
So thank you.
Thank you.